Electroplating by Dr. Balaraju, I thought I'll make mine somewhat technical, but I don't think I will be able to go into details of any great value because, again, I must say I've not been very active. I was introduced to electrochemistry in a very funny way. If I recall my student days, very long ago, we were taught corrosion and electrometallurgy without telling us anything about electrometallurgy or electrochemistry. We got to learn several things. We got to learn corrosion, we got to learn electroplating, we got to learn electrometallurgy, we saw the electrolysis, etc. But we were never told you must learn electrochemistry. Retrospectively thinking back, I feel if they had taught us the principles of electrochemistry at that time, we would have done much, much better than what we did today. I just tried to say, look at what is the state of electrochemistry. One publisher sent me this picture asking me to select 5 titles that he would present to me, and I think I selected 5 of those, and I have all of them now. But I don't know when I read it again. Electrochemistry is something that is seldom studied. Many people think electrochemistry uses something. They don't realize that it is a very, very important subject. It is all around us. When you look at lightning, batteries, all of you carry the mobile, it contains a battery. That means there are millions and billions of batteries around. Corrosion of metallic materials around us. The hybrid autos which are coming in a big way. The CO smoke detectors, the glucose analyzers or the glucose meters, and many, many more. All of these rely on basic electrochemistry. In order to understand the electrochemical phenomena, we need to have an understanding of some basic concepts. Right at this time, I must tell you, I'm not going to many details of electrochemistry. I'm sure in the audience, there are experts in the field, and for them, it may look like a primary class lecture. I'm sorry for that. Please excuse me for that. But however, I just thought I will take you along and show you what are the things that electrochemistry has done to us. I was very happy to see that the class 12 text contained reference to electrochemistry, and it was included in the syllabus of the chemistry chapter. And this is the picture I got from one of the class 12 texts, definition of electrochemistry. I was very happy about this because if they're going to teach you at a very young age, you're going to pick up much better. Study of chemical reactions which take place at the interface of the electrode, usually a solid, metal, or a semiconductor, and an ionic conductor, the electrolyte. That is what is electrochemistry about. It's also the interaction between electrical energy and chemical change. It can be defined in a number of ways. But a simple definition like this is sufficient for us to understand some of it. Of oxidation meaning the loss of electrons, reduction meaning the gain of electrons, and the idea that all the time, therefore, if some electrons are lost by one substance, it should be gained by another to maintain the system neutral all the time. The substance that loses the electrons is referred to as a reducing agent because it helps the other gain the electron. The substance that gains the electrons is referred to as an oxidizing agent. This simple concept that we have presented in this slide is an important thing in electrochemistry to understand many things, and it is sufficient to understand. Whenever we say electrochemistry, we always think of cells. We have depicted here some very simple cells, one on the left side, the anode and the cathode, and the power source, the electrolyte, the anions and the cations. And we have a cell on the right side here, where the electricity generated by the cell lights up a small element. That is, it's either the pulse. At this time, I want to say, although this concept of electrochemical cell is almost 2.5 centuries old or more, presently people are thinking in terms of generating everything in the solid state. And in this corner, right below corner here, is depicted a schematic diagram of a solid state cell. Cells that we're looking at, which have generated thousands of electrons. The one on the left, the galvanic cell, where energy released by a spontaneous reaction is converted to electrical energy. So this power source, you have on some big background noise. On the right side, we have the electronic cell, in which the electrical energy is used to drive some non-spontaneous reaction. We have here electrical energy work in the cell, which can do very, very important things. Types of reactions. People also think in terms of what is cell. We as metallurgists, we know it very well. You have two areas of two different stations. There is a potential and that can to derive. So here we are talking in terms of two half cells having the same electrolyte at two different concentrations. In such a cell, for example, two zinc electrodes immersed in zinc sulfate solutions at two different concentrations. So here is 0.1 molar and 1 molar solutions, and that can also be a source of power. But little cells that we showed look so simple. And people might think, we just set up a cell and we can do many things. In practice, they're not very simple. There are certain parameters which influence the whole system, its performance. There's some noise in the background.
And some people who are joined late, they are not muting their mic. Please have some courtesy. The speaker is getting disturbed. Those who are joined late, please put your mic in mute condition. Don't unmute and keep it open.
So although these cells are very, very simple to look at, they have given rise to very huge industries. And the difficulty in setting up something new is because there are virtually tens of parameters that influence the system. I've written here some examples. It's not an exclusive list, complete list. For example, when you look at electrodes, the size, geometry, state, relative area, material composition, mechanical condition, surface condition, conductivity, cleanness, etc. All of these are parameters that influence the system and system performance. The electrolyte can have different compositions, nature of ion, viscosity, temperature, presence of impurity, external and static, and so on. We could simply look at all of these parameters, and the reason why everybody does not do everything, people focus attention on some particular thing and look at all their parameters and control them. to have what is called as the Electromotive force series, the EMF series. And we can put all of these in terms of the electromotive force, lithium on top. Here, minus 303.03. We are having at the bottom here chlorine, plus 2.87. And we can list the entire list of elements that are in the periodic table, but usually we don't use all of them, so it is normally useful to consider a certain number that are normally used in everyday practice. Now, in the case of metallurgical studies, when we were taught, we were given this series, the electrochemical series, and we put all the metals here with hydrogen in the middle. So all those metals on this side have the negative EMF, and below this, you have positive EMF. I just want to make here a small anecdote that happened when we were being taught. One of my friends wanted to remember this whole series, so he made a small Namag Alasik Profek Cat Lay. So we could remember this entire thing up to hydrogen by looking at that, and then say add calcium, potassium on top, copper, silver, mercury, gold, and gold. Made a formula to remember all these. Very, very ingenious at that time, but it was very helpful for us to get the EMFCs. On this side, you will see that as you go from bottom to top, your metal activity increases. On this side, when you go from top to bottom, metal oxide activity increases. Having the electrochemical cells, we are jumping to looking at what are the various applications that the electrochemistry cells have generated. This is not complete. They are not complete. One of my friends gave me this slide to show that these are all the things that you can see. The ones given in the area inside here show the major areas, and the ones described on the outside show you what are the details of what are being generated. Right now, I think I'm really worried about distribution control. So I'm working on some of these, like metal recovery, the e-waste handling, recycling of things. Sensors is the most important thing that is, especially in healthcare. So we need to take a look at electrochemical sensors, and I'm also involved in a couple of these developments. Everybody looks at energy because we have an unsatiable desire for amount of energy required, and we can look at all these energy. For example, the batteries, the fuel cells, and so on. I just wanted to project this slide just to show you it is possible for somebody to keep some details of how it happens, what can take place, and what are the reactions, and so on. But honestly, I don't understand much of these. It's a very useful thing for somebody. And there's one more similar one where I thought it's a very beautiful slide doing all the things. For example, in which the red cell reaction, what is involved here, transport of ions between two cells. So like that, the whole thing tells you in a nutshell what is happening in an electrochemical cell. This is what I would be interested. What does electrochemistry give us? Most importantly, the energy storage, namely the batteries. Presently, you can say the batteries are about 250 years old, but probably much more. Corrosion, because everybody wants corrosion. The types are every day around us. And sensing, some of these sensors and so on, how to generate signals and so on. We must know that the advent of electronics, where the signals can be amplified greatly in a large fashion. Very small signals from these cells can be taken up and used for sensing, and therefore a large number of sensors. Electrolysis is picking up interest again. People thought we can just electrolyze water for its large amount of oxygen and hydrogen. It's not so simple. I will not be talking much about energy conversion and organic synthesis. I'll only be just touching energy storage, corrosion, and industrial electrolysis. Just to show the same slide in terms of some pictures, fuel cells, batteries, corrosion, and electroplating. The galvanic cells are being applied in two areas majorly: fuel cells and batteries. Stored and one of the most commercially used products. Now, if you look at a battery, 4 billion people have the mobile phones in their hands, and each mobile phone has a battery in it, so you can know how the battery has penetrated the lives of people. This is what I wanted to say. I'm very fond of looking at this picture because this is probably 4,000 years old. This was found in the outskirts of Baghdad near a pyramid, and they found out it was nothing but an energy source like that. It had a iron rod going through the lid, surrounded by a copper cylinder, and when filled with vinegar at that time, it would generate between the two electrodes a value of 1.1 volts. Later on, they have found several of these, which means that they knew that chemical energy can be converted to electrical energy at that time. The pyramids are 4,000 years or more old, and these probably will be as old as that. That means the battery knowledge, without the name battery or anything, was known at that time. The batteries have two types, all of us know about it: the primary batteries and the secondary batteries. The primary is one in which the cell reaction is not reversible and therefore cannot be recharged. We all know about dry cells, the plancher cells, and so on. And the reactants have been completely converted to the products. No more electricity is produced, and the end of the battery. The secondary battery is of more greater interest to us because in this cell, the reactions can be reversed by passing the electric current in the opposite direction in which the energy is being generated. Thus, it can be used for a large number of charge-discharge cycles, and therefore there's a life for it. And all of us know that the lead-acid battery has been there in its original form almost for such a long time. Even today, if you want to have a very reliable power source, people think of lead-acid batteries. Nickel batteries have also been there in place, similar to this, as their secondary batteries, but they are more expensive and they have some other problems. The lithium-ion battery is the most recent one, and that is going to probably rule battery. I'm not going to details of these. That's how the rifle is constructed. That's a lead-acid battery with the lead plates and lead oxide plates, and charge discharge. The lead oxide reaction gives you charge discharge here, and that we call it the lead storage. I'm going to have a very special lecture only on these primary batteries. Just to give some idea about these primary batteries, because we see it almost every day in our life. This contains a graphite rod and a zinc casing. The graphite rod is the cathode, the zinc casing is the anode, and there's an ammonium chloride in chloride solution, which gives rise to the electrolyte. It forms the electrolyte, and when the electrons of the electrolyte for generating reduction of reactant. The electrolyte carries the current from the zinc anode to the carbon cathode. Say that although it appears it can keep on going continuously, there is this limitation that the zinc casing is oxidizing at the anode surface, while the manganese oxide is reduced at the carbon cathode surface, and ammonia is then produced, decreasing the cell current by forming a gaseous film around the carbon. So this logically therefore sets a certain life for the cell, and therefore the cell does not live forever. It is having a limited life. And sometimes we say if you work it continuously, it has a shorter life. Sometimes you stop working the battery, it picks up some life, it regains some life. But these are all some details. I thought I will also give you some nickel cadmium battery, the nickel cadmium cell here. So details are given. I think any book contains these details. I think there's no need for us to go into details of this. But please note that nickel cadmium battery is supposed to have what is called as the memory effect. And therefore, when you want to charge and discharge the nickel cadmium batteries, it cannot be done the same way as you do a lead acid battery. And this battery will have to be charged only when it is completely discharged. Battery is on lithium-ion batteries, mainly because the energy density is much higher in material. The amount of charge that we get is much higher in this. We call it the newest rechargeable battery. It is based on the migration of lithium ions. The anode is a lithium metal. The cathode is oxide or sulfide that can accept lithium ions, normally manganese oxide. And the electrolyte is something lithium contains lithium chloride in organic solvent. Solid state polymers are also used, and when this combination is made into a cell, you get a cell potential of 3 volts. So lithium-ion batteries are such a big way. Everybody is trying to find out how can we make this lithium-ion battery with a higher power, higher life, faster charging, and so on. And there have been a lot of solutions, and people have come up with many types and many variations of the lithium-ion battery. It has occupied so much space in our life. Modern devices such as the mobile phone, laptop, iPad, and many others would not have reached the level of miniaturization and sophistication that we see today. So all that is because of it's how the lithium-ion flows into the cathode anode area. I'll also just mention about the fuel cells. It has not been studied as the fuel cell batteries, except they're also like batteries, but except that they are continuously receiving an external supply of hydrogen gas as the fuel and oxygen or air as the oxygen to form water. We are continuously burning hydrogen here as the fuel in the fuel cell. The anode and cathode have properly designed channels to transport this water with the hydrogen or oxygen gas and also take away the water that is formed. At one time, I just also was playing with the idea of manufacturing fuel cells. So I got an offer from a Russian company saying you can make one which can give you power up to about 1500 watts. I was taking a look at it, but then we found operation and maintenance is a great flaw. The fuel cells, although they have reached certain level of sophistication, are still not greatly used in commercial. There is only in certain particular places where others may not find suitable place to work. The electrochemical reactions in the fuels are simply burning hydrogen, and hydrogen and oxygen combining from water to give a voltage of 1.229 volts. The hydrogen cation in the anode half cell crosses the platinum catalyst coated porous membrane. Please note that we need a certain catalyst, and the catalyst almost controls the whole system. To react with the oxygen within the cathode half cell to form is carried away to the simple mechanism is powerful enough to produce energy for implantable devices and portable electronic devices. Although we say we use of fuel cells in a large way and unlike batteries. I just want to jump to the next electrochemical process, namely electroplating. I'm very electroplating only because my first project after joining engineering was on electroplating. The person who taught me electroplating, he told me, we all do electroplating, but I want you to do a very novel experiment. Imagine this was 50 years ago, and he told me, make a composite plating in which you have alternate layers of copper and nickel. Nickel are both plated very beautifully. So I did produce that. Each coating or each film was roughly about
सिया
100 millimeter
एक
thick,
मिनट
and we built something like
इलेक्ट्रोप्लेटिंग में
60,
पॉजिटिव से नेगेटिव में
70
जाता है ना
layers.
कोटिंग हाँ जो पॉजिटिव होगा
Please
उसे नेगेटिव में जो कोटिंग करनी
please. We built films of the order of 2 to 3 millimeters, and we found that the material had very special problems. Unfortunately, at that time, these composites had not come into vogue, and we did not pursue it further. But I still have samples of those which I produced at that time. That's why I think electroplating is something very special for me. And later on, I've dealt with plating of copper, plating of chromium, plating of nickel, plating of copper. So, electroplating is an application of electrochemistry that started a very long time ago and has grown into a huge industry, very huge industry. Surface, they are transferred from solution and are deposited as a thin film onto the surface of the glass. And this job is done by the electroplating. The setup consists of a with an anode and a cathode sitting in a bath that has the metal ions necessary for coating. This looks like a simple one with blue on the right side here. Copper and nickel, we have just two anodes here and the power source, and the nickel can plate onto the copper with copper pattern. Plating has made all properties of the base metal at the surface. The base metal need not be a metal, it can be an alloy also. And even the plated material can be a metal or it can be an alloy. Piece of metals, all which can be plated. This is not all. You can plate any combination of this also, depending on what is required. And people have used it in a variety of ways. People have plated on here. You can see the concepts on the part that is shown on the right side here. And also you can see particular material which is so complicated, so nice, and that also can be. So electroplating can be carried out to produce a variety of objects with variety of surfaces. Chromium has been the workhorse of the plating industry because chromium is plated to produce a very hard surface, very resistant surface. Somewhere that the total amount of chromium plated is at least 100 times more than the total of all of the plated. That's the kind of thing you can get it from. It is most used in the industry to enhance wear and corrosion resistance. I've given this picture mainly here because I was involved in plating of chromium on a very large shaft where they used to produce, and they used to have a lot of problem in preventing corrosion during application of the coat. Although they were coating some 30 microns of chromium, it still used to corrode. This decorative thing is an automotive wheel, and that shows what kind of applications it can go for chromium. Precious metal plating is very different from this because the plating is not so easy. And also, the plated metals are so expensive, so you have to have very good control over it. The advent of electronics industry saw great developments in precious metal plating. You know that in all electronic industries, when you want to make connectors and connections, gold would be the ideal thing because it would not corrode and therefore gives you very ideal connections. The jewelry industry has made use of the electroplating to a great extent, and they can produce a variety of surface finishes in jewelry manufacturing. So we're looking at decorative coating on the one hand, aesthetic appearance, and on the other hand, engineering coatings with the special properties like hardness, wear resistance, corrosion resistance, and so on. So electroplating has developed into a major industry. Although we normally say electroplating, it also refers to electroetching, electroforming, electromilling, anodizing, coating on non-links, and variety of others. All of these, I think you have a lecture by Ms. Chandramani. We'll also talk about several of these. Here's an interesting slide which says that it is possible for you to control your parameters and method of plating to get high-speed electroplating. And this figure that has been generated here is generated by instructing the electroplating process here to produce this. For example, trace the topography, leave the positions, retrace the position. So when you have this closed loop plating here, we can produce a very large high speed of plating and find the problem. And this has led to what is called the 3D printing now. And very recently, we have seen the 3D printing of an electrodeposition has opened up immense possibilities. The only thing here is to control the rate of plating so that we can get objects in measurable time. Electrolysis production of has been a really good example of molten salt electrolysis. Of course, as metallurgists, we have learned a lot about these aluminum production methods, and this is another electrochemical process which has great applications. On the right side, you've shown here that the aluminum produced is not so pure, though it can be purified. Of solutions, gases are usually one type of a gas at the anode, another type of gas at the cathode. The gases produced can be collected suitably and used. The electrolysis solution is more complicated than electrolysis of molten salt. As well as the water. When it involves water, that's what happens. Oxygen and hydrogen. And this has been known ever since we know electricity. People have thought that we can make use of this simple method to generate hydrogen for use as a fuel. But for a variety of reasons, it has not picked up that kind of importance. It is still not used as a major source of hydrogen. People are still thinking of it probably is not commensurate with the cost of fuel that it will be. But electrolysis of water is definitely a possible source of. We then jump to corrosion. I'm not going to spend too much time with corrosion because I think Mr. Raja is going to speak to you completely on corrosion. Corrosion is simply a loss of reaction with the atmosphere and chemicals. And this definition does not tell you where is electrochemistry. Corrosion leads to a huge loss of property and collateral damage. Corrosion of various types are typical examples of electrochemistry. So we are saying that, but we need to show in every case what is the electrochemistry involved. If you look at various types of corrosion, when you dip a metal piece into an acid, dilute acid, it corrodes. It's a chemical reaction. People say it's a chemical reaction, but we can show that between the grains of the metal there are differences in potentials, and that probably triggers the reaction. Galvanic corrosion, similar metal corrosion, pitting corrosion, stress corrosion, corrosion fatigue, mechanical corrosion, and a variety of other types. In all of these cases, we can apply principles of electrochemistry to create procedures and processes to control and measure corrosion. The electrochemical nature has resulted of combating corrosion. If you just say metal corrodes, you will not be able to control it. If you say how this happen, what are the parameters of control, we can find out methods of combating it. For example, various surface covering methods would say, I'll separate the electrolyte doesn't take place, such as painting, coating, surface treatment, and so on. Cathodic and anodic protection, where we make use of electrical energy to make a material more cathodic to protect it. And these cathodic and anodic protection can be for bridges, pipelines, offshore structures, and so on. And all of these, you can see they are very large structures and still can be controlled. We have to be always very careful about environment. We talked about a variety of electrochemical processes that lead to very big industries. Okay, but electrochemical procedures also are great source of pollution of various kinds, and we need to be really worried about. Things very small, 100 years ago, 20 years ago, people never bother about. But people, for example, they threw it into rivers and lakes and so on. But today it's no more possible because the industries have become so huge, giant-like. As an example at this particular electroplating, which has been in vogue for thousands of years, has developed into a major industry which uses extremely lethal chemicals. The plating process itself, little risk if performed correctly. Carelessness causes the most damage, and that's what we're going to do. The electroplating industry, for example, is considered a major polluting industry because it discharges toxic materials and heavy metals through wastewater, effluent, air, or vapor emissions in solid. In the very recent time, we know that the 400 odd electroplating industries around Bangalore were given a notice. And there's a very big problem. If the effluent goes into a lake, for example, the heavy metal content of the lake can keep on increasing. To get the effluent and throw it in the landfills, it is possible that these heavy metals will find their some tree or some plant structure and the cow eats that, and it's milk we eat, and it comes back. So there's a variety of ways in which the industries are causing problems, and I think we need to really look at how to combat these polluting industries. I just have some statistics here to show that it has grown so big that we are not able to control it. The electroplating industry in India, for example, has grown to reach about 3,000 crores, but it will reach about 3,000 crores by 2030. While the organized sector uses about 18,000 tons of chemicals, the unorganized sector uses about 10,000 tons. And these are huge quantities. And where are they going? We don't know. Very important industry for economy. But the automotive industry, there are so many things are depleted. Electronic industry, there are so many things are depleted. Electroplating industry is a very important industry for economy. But at the same time, it is not a speed. So therefore, it's a major source of heavy metal pollution and surface gas. What is the need of the hour? Therefore, we have to make a focus our attention on specific problems and methods to tackle the pollution. This is true of not only every industry uses large solutions are not in sight. Since we are dealing with these, we really know how difficult it is to control this pollution aspect. If somebody knows some very efficient methods of pollution in the electrical industry, really I want to close my lecture with two examples. One in the industry. We all know that people use glucose sensor measuring their sugar. This little sensor here is made of the details given on the right side. It says how does it work. So we have an electrode there, and we have got the small signal coming out, and we measure the signal and calibrate it in terms of the glucose content. For this particular reaction, the bicatalytic reaction is responsible for the signal that's coming out of this small little thing and we measure. And therefore, you can see electrochemistry has entered into the healthcare area in a variety of ways, and this is one example. The next example is about subsidized solar cell. I was very excited to see this because this kind of solar panel can give you higher efficiency at a lower cost, and because there are no moving parts, and because the solar energy, the sun's energy is free of cost, the whole thing will be economically viable. So somebody is working on that. These are the details of that, how we can put in the electrodes and so on, and how to get the PV power out of it, and that the solar panels that come out in the next after about 6 months from now, this particular kind. I don't know how much it is. Recently, the efficiency is around 11-12% of the silicon solar panels. It can increase to 16-17%. But people are now saying, can we look at 40% in the solar cell? I am not very sure if that figure can be reached, but even if it is at 20-25%, it is really worth it. And we would like to see developments in this area also. I understand this picture, but I thought it's a very beautiful picture, so I just put it as the last slide. And the visible light, infrared here interacting with this, producing a certain visible signal, and on a metal electrode, and certain things happening here. We get a photo current voltage measurement. I do not understand this, but I think I thought it was a very beautiful picture to put it. Thank you very much. The subject is so vast that we know some batches. We don't know. We still have to learn a lot. Thank you very much for your very patient listening.
Thank you very much, Professor. So it was a very good talk covering different electrochemical science and technology, especially how different engineering in different technologies using electrochemical basics. It was a really very good thought-provoking talk, especially for young people. So now it is open for discussion. Anybody has questions, you can unmute and
Sir,
talk.
can I have one question, sir? My name is
Please,
Dr.
sir.
A.K. Shukla.
Yeah, please.
First of all, my gratitude to Professor Dwarka Das ji. I think I know him. I have met him at several electrochemical conferences in IISc. My pranam to him, first of all. And my question is very general because I'm grateful to him that he has revised the complete electrochemistry in a very simple way in the last 1 hour. Dr. Barka Das ji has talked about developments in fuel cells, and he referred also that some Russian company approached him for the manufacture of fuel cells. So, but further he has not deliberated. And now my question is, what is the present status of fuel cell manufacture in India as such? Because I'm not sure who is manufacturing, or even developments are also in bits and pieces in certain institutes at the research level, only the work is going on. But what about the manufacture? So I would like if you can throw some light on the present status of fuel cell production in India. The first question. Second is, the key component is polyelectrolyte membrane, for which we always depend upon either America or Japan or Germany. So is there any source where the people are working on membranes and we can develop, or it is being produced in India either anionic or protonic membranes? I would like to have his views on this, sir.
Good. Thank you, Dr. Shukla. Say good evening to you.
Good evening, sir.
Thank you for those very kind. They mentioned about the Russian arm. I think people should mute their mics. A lot of noise in the background. They made this offer in 2000, and they told us
Yes, sir.
1500 watt would be about 5 lakhs. I mean, that itself was very, and we were not able to deal with that. I know fuel cell research is not very popular in India yet. I know that the BHEL R&D in Hyderabad was doing some work, but I've not heard anything from them after that. Any fuel research in India is only at the laboratory level. If
Laboratory level,
some
yes.
other research, I think I would like to hear about it. I've not heard about it. Regarding the membrane, several people are working on it, although I don't know the details of that. But there is an effort now to say we should make our own membrane material. We are depending a little too much on imports. Again, I said I'm not active in the field for almost 10 years, so I don't have too much contact with the research groups. After starting my industry, I think my interests have all gone to sustaining the industry rather than doing it.
Development.
Your question is very nice, very important. I should find out some answers, then I'll get back to you.
Sir, one more question I am having, very relevant. You have spoken about electrolysis of water, converting into hydrogen and oxygen can be a good source for hydrogen for the hydrogen oxygen fuel cell. Now the question arises, for electrolysis also you need power. So what is the cost difference between electrolyzing water and using hydrogen oxygen to generate electricity in fuel cell? Suppose, because the oceans are full of water, or even ordinary water can be used for electrolysis. But the question is how much power we are consuming here and how much power we can generate in hydrogen oxygen fuel cell. Is there any advantage?
No, that's what I mentioned. Because of the power problems, this electrolysis of water as a source of hydrogen has not talking in terms of what being and so on. I are looking at it in a different way. Very soon we will know if there is a source of hydrogen from water. Right now, I do
Sir,
not know of any place where they're using it or as a source.
sir, I have one comments
Thank
here.
you, sir. Thank you very much.
Hello, Dr. Shukla. I think
Yes, sir.
photocatalytic hydrogen generation is getting popular, and there
Yes,
is
sir.
lot of progress in photocatalytic generation or water splitting for
Okay.
hydrogen generation.
Any cost
So,
advantage, sir, in that?
basically, it uses sunlight as an energy source to split
Yes, sir.
water.
Yeah,
So,
I got it.
yeah. Okay.
I
So, yeah, please, sir.
Thank you, sir. Thank you.
know about not been very successful.
Yeah, and sir, in fact, in Japan, one national institute has already demonstrated several meters of photocatalyst coated technology to generate hydrogen generation through photocatalysis.
I know about that. I know about that Japanese thing, but it has
Yes.
not been successful yet. That's still what.
Yes, yes, sir. Yes, technology is under development.
Yes, definitely.
Investor, you can take the
Thank you, sir.
Yeah. Any other questions? I think there is one. If there are any other questions, I will just see chat box. One, Mr. Kumar is asking, is there any new technology related battery is being developed? Professor, there is a question from Mr. Kumar.
Yes.
Is there any new technology related to batteries being developed?
Yeah, presently, I think most people are how to charge the battery very quickly, how to increase the life of the battery. I don't know if you heard of the million million charge battery from Tesla, from Elon Musk. I really do not know what he means that the that particular battery. But we had a small meeting about a year ago in the Institute of Science, where one of the persons came and told me that he has found a technique by which he can charge the lead acid battery in just half an hour, 30 minutes. And that one Bombay company has taken up his technology, and those batteries will be available by January 2021. If that comes in, I think lead acid battery will again come up in importance, because you can charge it in 10 minutes, means just walk into the station, plug it in, have a. But otherwise, I think most people are concentrating on lithium batteries. You can ask me why I have interest in lithium batteries. After the time when the first company I started was in lithium polymer batteries, and we wanted to make certain bit. Unfortunately, what the company that was selling me the cells in Malaysia closed down. We didn't have any source, so we have to close down. But I think we are following very closely the research groups, trying to improve the lithium-ion cells, lithium-ion battery, that they can charge very quickly. You will notice that lithium-ion battery will work very well only if you have a proper battery management system. Otherwise, it's gone. If you discharge it completely, it will not charge. If you overcharge it, it's going. There'll be fire hazard and so on. So the very good battery management system, along with the batteries, are very, very important requirement. And we are also working on it. We means my company.
So next question is from Nikhil. What are the alternative ways to increase storage capacity of any battery?
I think there is a small booklet that I saw while going through these of storage batteries, and there was a two-page write-up on the methods of storage. I think I can refer you to that particularly. I can get that answer.
I think there is another question. Satpal, if you are there, you can directly ask question. Satpal, your question is long, so you can ask question.
Yes, sir, I'm here. Can you hear me all?
Yeah, somebody has
Please,
metal
please.
oxide playing important role in electrocatalyst. Electrocatalyst is not my field. I'm sorry.
Hello, am I audible?
Yes, you are audible.
I asked that in current smartphones, the battery is charging very rapidly, sir. I want to know, like, what is the mechanism that goes behind?
I have no general answer for that question. I have an answer your question in the lead-acid battery that we were talking about the fast charging. When you charge a battery very rapidly, what happens? The current passing through the electrolyte is very large, and therefore it heats up very rapidly. And sometimes it does not even charge. They sometimes say there's a limit current that you pass through the battery for charging. This person who told me about fast charging of the battery told me that it's a patent secret and he doesn't. But you get a lot of answers to this any battery.
Sir, I think these days
charging.
people are using nano-based electrodes where charging kinetics are very faster compared to traditional electrodes. So that is one way people are trying to increase the charging rate. They are using graphene-based or nano-structured-based electrodes. So because of that, the charging is getting faster than before, especially mobile phones.
Yeah, I did not.
Yes, sir. Another question. Shashank Bhushan Das. So there is a question from Shashank Bhushan Das. What are the different types of materials used in hydroelectric cells to generate ions? Sir, did you note that question? What are the different types of materials used in hydroelectric cells to generate ions? I think this is question is little out of the context what professor gave talk. If Professor Dasa, can you answer this question?
Can you repeat the question?
What are the different types?
Here?
Yeah, what are the different types of materials used in hydroelectric cells to generate ions?
Sorry, sir, I have not here.
Yeah. And sir, there is another question from Praveen Kumar. Why metal oxides play important role in electrocatalyst? What is the reason in it?
Well, somebody can answer it, I'll be happy about.
Basically, most of the metal oxides, especially transition metal oxides, they are active in their electrons due to their electrons in the outer shell. So because of that, most of these transition metal oxides are popular as an electrocatalyst. And also their potential is acceptable range. So, any other questions? I think some more questions are there, sir.
I have one question.
What are the biggest challenges for solid state batteries?
There is one which says, there's one question. Is there any new technology related to battery being developed? I think people are looking at metal air batteries like zinc air batteries, sodium batteries, and so on, which will have much better performance provided we can take care of the parameters that need high temperature, handling, and so on. All
There
these
is one
things will be
question
done.
from Sir. There is a question from Surendra Kumar. You want to ask? Surendra Kumar, you can ask question.
Please ask me.
Sir, good evening. I am Surendra from MP Bhopal. Good evening from Bhopal. Sir, most of people, what will be the reaction in electrolysis plating actually? Electrochemical reactions in electroplating.
Yeah. So, electrolysis plating also, even though we say it is no electrodes are involved, but reactions involved are electrochemical in nature. That means oxidation and reduction reactions are happening because of the bath, what are the nickel source, apart from that, reducing agent, complexing agents, all things are involved. That makes, due to the electrochemical in nature, whatever the reaction is happening, because of that, the coating always happens by electrolysis plating method. Surendra Kumar, are you clear?
Yeah, thank you. Thank you. Sir, good evening, sir. Thank you.
So, sir, next question is from Prince Kumar. He's a nanotechnology student, and he's asking what should be our aim as a nanotechnology student in the field of battery and solar cell.
I think we must all work towards finding a very stable lithium-ion battery, fast charging and long life. Long life is very important. Presently, some batteries die off in 2 days, will last 3 years. What are the parameters that control these? I think we should start working towards finding out what actually controls all these. Somebody asked that question. What are the parameters control? Oh,
So, next question is about the names of dyes used in the sensor solar cell.
nanotechnology will find. They have not given names of dyes.
Yeah, normally they use different organic and inorganic dyes. Some of them are ruthenium-based complex, and some of them organic dyes. So most of the dyes are commercialized, and they don't give full details also. Yes. Yes, sir. Yes. So, what is the biggest challenges for solid state batteries? From Mr. Mohammed Siddiqui.
The first challenge is to make the solid state cells.
Electrolytes. Yeah.
Selection of suitable materials to make it cell. I think it's a big challenge. I've not worked in that area, so I don't ask.
Yeah, basically, that electrolyte, solid state electrolyte with the proper conduction is the biggest challenge, sir. That is the main thing in the electrolyte, solid state batteries.
Was it?
Next question. Next question from Mr. Mahesh Shastri. What will be the future of lithium sulfur and lithium air batteries, because it is having high capacity compared to present batteries?
It is not lithium sulfur, sodium sulfur. Sulfur and air battery. They come into prominence. Take a look. First develop. can exhibit negative resistance? I don't. Any instance. Can electrolysis plating be done for plate material? All materials? Is it cost effective compared to electroplating? Balraju?
Yes, sir. See, electrolysis plating can be done on all the metals. Only the difference is you have to make any metal to be catalytically active. For that, a separate surface treatment is required. For example, if you consider mild steel, it is very, very simple to do the electrolysis plating. In the case of titanium, unless otherwise proper sensitization, activation treatments are necessary. Without that, it is not possible. If another question is it most cost effective compared to electrolysis plating solutions are expensive. Only the difference is here you get the uniform plating and it is possible to plate on any material, either metallic material or non-metallic material. And electroplating solutions are always cheaper. So that is the difference. Cost-wise, these are all expensive. Very carefully, these coatings should be utilized. And the properties, whatever they exhibit, is very, very. I mean, high hardness, high wear resistance, high corrosion resistance. All those things can be achieved. That's all, sir.
Yeah, electrolysis plating is as old as Egyptian pyramids. They found there inside the pyramids these small round glass spheres which are coated on the inside with a metal. I think that the only way to coat them is by electrolysis plating.
Yes.
Right.
So,
Iron, I've not heard of them.
yeah, iron ion battery is not there, maybe. Aluminium and other things are there. Shall I request Dr. Kamachi to comment?
Once answer this,
Thank you,
you will
Dr. Ganesh. And I think
have mobility.
it's a wonderful talk.
They want the lightest one. Lithium, potassium. Look at iron. The iron is so heavy. Mobility. I think that is will be thought of the present time.
Dr. Dinesh Rangappa,
Yes, sir. Please go ahead, sir.
I'm done.
we have listened for about nearly 1 hour. Professor gave a very wide coverage of the entire electrochemical science and engineering with beautiful examples. And he has touched even from the ancient historical days to what is the modern development that is happening in electrochemical science and engineering. It's like reading a novel or reading one full textbook on the various aspects and application of electrochemical science and engineering. And the Electrochemical Society of India is very fortunate that we agreed and delivered this overview on the electrochemical science and technology for the benefit of all the young students, research scholars, and the attendees here. And it is only the beginning. I am sure that each topic that what he has told, like Corrosion, Professor Raja is giving a talk. Then we will also have specialist lectures on batteries, fuel cells. Already electroplating has been given by Dr. Balaraju. So we are going to have different, topics of the electrochemical science and engineering by the experienced professionals one by one. And I am sure that you will continue to attend these webinar series every week and get benefited. And I have no doubt that this webinar series will be a very successful one. And on behalf of Electrochemical Society of India, I would like to thank Professor Dwarakadasa for accepting our invitation and delivering this beautiful overview of electrochemical science and engineering. Thank you so much, sir, for your availability today, preparing this lecture and delivering to all. Thank you, sir.
Thank you very much, sir. So now I will
Everybody, particularly to Dr. Shukla. He was there in the last
Some more questions
lecture
are there.
also. Thank you very much. Thank you.
Dr. Naxarup, mostly we covered all the questions.
Dinesh, still two more questions. We have another 10 minutes time.
Okay.
Yeah. Can you explain about not that, but after that, see about charging and discharging. One question is there, is it?
And that question is not clear. Is this not important to decrease the loss of energy during charge and discharging? I don't understand where is the loss of energy during the charge discharge. Question is not properly framed. But if
I think
we can directly ask, what is your question?
during charging and discharging, certain amount of energy loss. Correct.
Good evening, sir. Question is from my side.
Yeah, correct. Go ahead.
As I read about that, during the charging or discharging, 50% energy is losses. When you connect a capacitor with a battery, only 50% of energy will be stored in the capacitor, 50% is lost. Then, is this important to decrease the losses of energy during this?
50% is not right. Charging, you lose more energy. Charging, you lose less energy. But it is not of the order of 50%. It is roughly of the order of 20%. And in modern, it is 50%. Most of your loss of battery charge, if you fall it is fully, you won't lose so much. After closing the Malaysian supply, did you make one? we did not. I changed the thing to space thing, so we did not go back to the battery. Now I'm doing this for satellite.
Sir, in addition to your answer, I would like to tell him that basically in lithium-ion battery, the loss of energy capacity fade occurs because of extraction problem of lithium. Means once lithium get into the crystal structure, most of the lithiums will not come back. Reduction will not occur. If you take lithium cobalt oxide as a cathode, in that case it is around 40-50% capacity fading. Normally, lithium cobalt oxide as a cathode, it has more than 220 milliampere per gram capacity, but basically we can extract only 140 milliampere per gram capacity. So that is basically due to electrochemical oxidation reduction, and lithium will not be completely extracted, or that is the problem people are facing. But these problems mostly recent batteries are already solved by choosing proper electrode materials and all. This problem is solved, and by also using the nanosize electrode materials, so the kinetics has been improved. So most of these battery problems, and of course after reaching several hundred or thousand cycles, gradually these electrodes will fade. That problem is there. That is the intrinsic material problem. So that is after reaching its life of the battery. So otherwise this problem is mostly solved.
Very much, sir. Thank you very
Last
much, sir.
one more question. Last one question, because now we left with another 5 minutes time.
I think who is the last question from AKU Patna? I think Shashank Bhushan Das from AKU Patna, Aryabhatta Knowledge University, Patna. So, what are the nanomaterials to generate ions in hydroelectric cells? So, I think, Professor, again, this is related to hydroelectric cells.
Yeah, I think I can answer.
Sir, can you answer this question?
No, I said I will not be able to answer this.
Yeah. So, Mr. Shashank, I think hydroelectric cells experts are not here. I think maybe we are not sure about your question.
Yes.
So,
We will inform
Dr. Prasanna will conclude and announce the next week lecture, tomorrow's lecture.
and by looking into Dr. Dinesh,
yes,
I would like to inform the participants next week we will have an exclusive session on battery storage.
Yes. So of course we will have. See, this is basically inaugural lectures, which is trying to set the direction of this webinar and what are all the areas we are going to cover through this webinar lecture series. So I think on each technology, what Professor touched upon, on each technology there will be a specific lecture in coming days, and they will be exclusively talking about only each technology. So in this way, batteries, supercapacitor, electroplating, and other areas will be covered, and there I think definitely you will get your questions answered.
Dr. Prasanna, please.
To Dr. Dinesh Rangappa and Dr. Nagswarup. Before making the concluding, I would like to announce the tomorrow's speaker. Tomorrow we'll be having a webinar on effluent treatment and control in electroplating industries. It is effluent treatment and control in electroplating industries by PG Chandramani, is the retired manager, plating and painting BL, that is Bharat Electro Bangalore. Tomorrow sharp 4 o'clock. I request all the participants to join the webinar. We'll through email also. With this, I thank to complete applications of electrochemical reactions, and I thank Dr. Dinesh Rangappa, Dr. Nagswarup, and President of ECSI, Honorary President of ECSI, Dr. Kamachi Muduli, for making these webinar arrangements and choosing the eminent speakers and making the young researchers to listen to the great learned scholars. I thank all the participants for their presence, attendance during the session. Tomorrow, sharp 4 o'clock, 4 p.m., we'll assemble back with the shared link through WhatsApp and email.
Thank you, Professor.
Thank you, sir. Thank you very much. Thank you, Dr. Prasanna.
Thank you.
We'll feedback link through email and WhatsApp. I request your feedback.
I will put it in the group actually.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you very much, sir.
Thank you.
Sir, Nano TV, we thank ECSI and Department of Nanotechnology, thank Nano TV for live streaming of the webinar on YouTube channel.
Sir, this lecture was lecture was streamed online at a YouTube channel by Nano TV.
Nano TV.
Yeah, yeah, and every day, every week it will be there.
How do you access it?
Sir, this is from one
Live link is given.
live. I think Nagsarup will send the link.
That live streaming link is
Later
given
on,
actually, sir.
later on when you enter the YouTube, we need a link to go to there, right?
Yes, sir.
Yeah,
Yes.
Yes, sir. From this WebEx
We'll
to
share that
the
link, sir.
WebEx to that YouTube, the link is being live streaming link. From that it will be, sir.
Okay, thank you.
Going from
So,
that.
now,
Thank you.
Yes, sir. Please. Yeah. Dr. Nagsarup, can we download the talk there?
From there also, it is recording in our this one only, WebEx only.
Oh, okay.
like
Coming from here to there, it is I think some 3 to 4 minutes.
Difference, yeah. Understand.
Difference will be there. That the full entire session we can download it from our this one only. It is recording here only.
Okay. I think through this, I think many people are participating and attending the lectures.
Yes.
good.
Thank you, sir. Bye. Bye, sir. See you tomorrow, sir.
We'll meet you at 4 o'clock tomorrow.
Yeah.
Yes, sir.
See you, sir. See you. Thank you, sir. Thank you.
Dinesh,
Prasanna, yeah, please.
there are questions at
YouTube chat.
we make sure that we take questions from there. Yeah. One of
From tomorrow we'll try to.
yeah. Today we missed it.
From tomorrow we'll.
Yeah, tomorrow we'll take questions from here also and from.
Questions,
Okay, then shall we close?
Prasanna sir.
We'll
ಯಾರಾದ್ರೂ ಒಬ್ರು ನಾವು ಅದನ್ನ ತಗೋಬೇಕಿಲ್ಲ ಅದನ್ನ ನಾಳೆ.
Prasanna, I think from tomorrow we
will take.
can take. Yeah, please.
Tomorrow we will take.
Okay.
Better we list out the questions on a separate file in a Word file as soon as they are asked, or else there are chances of missing questions from the comment box.
Yes. I made a list. Yeah. I made a list. Yeah. I made a list. Yeah. Okay. Thank you. See you. Thank you. Bye.
हाँ 100 रुपये लिया भाई 100 रुपये
Thank you.
बोला ना 500 रुपया ऊपर से आता है ऊपर से आपको तो डिमांड बहुत ज्यादा है कमाई हमारा है नहीं आपकी डिमांड ज्यादा है बहुत डिमांड है
वहां से आता तो ये आपको एग्जिट आता होगा कहाँ से आता है? ऐसे ऊपर आराम से क्या सर? यही पानी बचेंगे 3 रुपए देंगे तब पोछा मार देंगे पूरा यहाँ पे।
मास्क है आपका, मास्क नहीं, मास्क नहीं आपके पास? मेरा मास्क के घूम रहे हैं। नकवा जाम बीमारी होगा तो ससवा जाम हो जाएगा।
क्या बोला तुमने? स्केल चाहिए?